who are coming back, welcome to the new folk. Just want to do the preamble that thanks to the Royal Astronomical Society of Canada, the RASC, for setting up the Zoom account. Also to thank Luca Vanzella, John Stolte, and notably Berta, who's here. She's keeping a watch on the chat side of things, just in case. Everyone is allowed to unmute themselves. If you want to ask a question, go ahead and sort of interrupt, unmute yourself. Otherwise, make sure you're muted to just minimize any background noise. This monthly get-together is somewhere between a book club and a course. The idea is to introduce you to the sky, the stars, the planets, much as if we were sitting around a campfire looking up, or as originally planned in a small group at the Queen Elizabeth Planetarium, where we'd talk a little bit about what the different things are we can see, and then walk outside and look up at the sky, use a small telescope to show you what's possible. But since we can't do that, we're Zooming. And so first and foremost, this session is all about looking with your eyes. No telescope is required. Binoculars are great if you have them. But will not be covering black holes or stellar evolution or cosmic rays or neutrinos or anything of that sort. It's really all about just using our eyes. I think one of the things I want to emphasize every time is it's really crucial for you to actually step outside just about every clear evening possible, even if for just 5 minutes, to look up and go, oh yeah, there's Vega, there's Altair, there's Deneb, there's Arcturus over there, and just sort of get into the feel of where the stars are, and the gradual change in the pattern month to month, where the planets are. And essentially, this is how you begin to learn your way around the sky. I've designed these sessions more or less so that you can sort of enter the loop like a merry-go-round at any point. What we said last month or 2 months ago, you can get away without actually knowing, and just sort of pick it up as we go along. On the main web page that featured this meeting, there's some links to how to look for satellites, moon map, an image of the sky this month, and especially a link to the Explore the Universe certificate from the Royal Astronomical Society. So it's a PDF of a handful of pages printed out, and not quite follow along, but generally use it as we'll identify a few things on the charts tonight, and you can go out and say, oh, yes, I did see the planets. Again, please interrupt me when I go and say something that you don't understand, and we'll sort of stop and go back and explain it. Once, a long time ago, I was like some of you who started with a bare minimum and just sort of learned. So sometimes I kind of forget about that. But so today's session is, we're going to look at an observing log, and we'll be starting right off the top with Berta. And then we'll move into geosat flares, binocular doubles, and the Orionid meteors. So with that, I am going to share my screen, and we will go right into, actually, to find PowerPoint. There we go. And I need to, here's my little, there it is. There, so that should be it. And Berta, just tell me when to advance the slide. When it, there we go.
Yeah. So I thought I'm a avid journaler in every aspect of my life. I like to keep logbooks of everything, being work, being hobbies. And so I really like the aspect of keeping and observing logbook. And so first of all, I wanted to say, why a lot of people do that. And so first and foremost, of course, a logbook serves as a personal diary of your time spent outside. And it's a way of tracking your progress in this hobby and seeing how good or how you can advance in recognizing the sky, or how can you learn to find things with your telescope, or look back and remember, oh, 2 years ago, I could only see this, and now I'm already seeing things 3 times more faint, or some more fun, or I found that maybe solar observing is what I like, and I was doing planet observing before. And so one thing that I find very interesting is to actually consider sketching the things that you see with your eyes, with your binoculars, or just through the eyepiece, because that actually helps you to observe things and to spend some time enjoying them. Because if you just see something in your eyepiece and you look at it and you say, okay, I saw it, and then you leave, you haven't even spent 10 seconds at the eyepiece. Where if you're going to sketch it, and the final result is completely irrelevant. It doesn't have to be a masterpiece of art. It's something that it maybe reminds you later on what you saw. But the fact that you spend some time drawing it is going to help you see features of the object that you're seeing. Seeing a galaxy, you may see faint arms, or seeing a nebula, you may see darker and brighter areas. And so things that you may have missed if you were not drawing, then if you just spend 2 seconds looking at it and then decide to move to the next object. And so here on the right, I'm showing a page from a logbook of a person called Randy Pakan, which I haven't unfortunately met, but he was from Edmonton, and his sketchbooks are just so beautiful to look through. The RASC has a repository of sketchbooks or logbooks, astronomy logbooks from because not everyone draws. So sometimes people just write, and that's fine too. Sometimes people record. You, Alistair, you said that you do that. You record with a voice recorder. So there are a lot of ways that you can record as long as you see. You can draw, you can write, you can talk to a machine. It's just a way of spending time seeing and observing what you're looking at. And so Randy has beautiful logbooks that are in the RASC repository of logbooks, which I link at the very end of this presentation. I have a link to that. So if you can go to the next slide, please. And so what can you write in your logbook? Of course, it's just your logbook, so it's to some extent your choice. And as I say, you can write it, you can type it in your computer, you can record it with a voice recorder, you can do astrophotography and write it later. But one thing, normally what things that are considered necessary so that you can look back and remember what you saw and compare to different times of different seasons is you should write the date, the time that you start your observing session, and the time that you finish. Your location being in Edmonton, my backyard, or Blackfoot, or wherever you've been observing. The weather, of course, you want to see if it's -20 or +20, just for remembering sake. And also, as you get experience, this is also something, the seeing and the transparency of the sky is an important piece of information that helps you, because it matters a lot in the kind of detail that you can see in your objects. But it also requires time to being able to appreciate if your seeing is good or not, or your transparency is good or not. It requires a little bit of experience. So the beginning is just okay, saying, the stars twinkle a lot, or the stars almost don't twinkle at all, and that's okay too. You want to write which instrument you were using, because if you continue in this hobby, eventually you probably will go through several different instruments in your life, and so you want to remember which one is the one you use for that observation. And of course, this is kind of like the metadata, what you write at the beginning of your observing session. And then for every object, you wanna write which object are you looking at, being a nebula, a galaxy, a star cluster, a planet, the moon. And then, oh, sorry, I misspelled that. Okay, I'm I'm a terrible speller. I meant to say sketch. I read sketch. Okay. So you may want to sketch it, as I say, not to create a masterpiece or something that other people have to see. Maybe you don't show it to anyone ever. It's just a way for you to actually pay attention, not so much to make art, but just as a way of paying attention. And then you want to write personal notes, how you feel about the theme, how you feel about the night, how you feel if you want to, or you can do it more scientifically and write, details of the night, or how many satellites do you saw passing by as you were looking, or things like that. And then something that you may want to write at the beginning of your logbook is an index of your observations, so that for every logbook, if you say you want to remember, or you want to say, oh, I want to see when I look at the Crab Nebula 2 years ago, you don't remember which page you wrote about that. So at the beginning of the logbook, you always kind of keep an index that makes it easier to find which page is that you wrote about that, because maybe 2 years later you observe it and make a different sketch, and you want to compare your skills or how good the night was, or things like that. Can you please go to the next slide? Mm-hmm. And so from here, and so that's basically, from here on, I'm just gonna show some examples of different sketchbooks or logbooks that I've taken all from the repository from Rask. So these are books written by Canadian people. And as I say, if there's some value being scientific or aesthetic or just as a record keeping, you can donate them to the Rask, and they scan them and keep them in this repository. And so the first image is solar observing by, I think he was from Halifax. I actually forgot now. A person, Rehen, in his sketchbooks from 1983 to 1995. He has every page 4 discs of the sun, and every day he just writes this little detail, just the date, a little detail about the sky, seeing the transparency, and then he draws the sun with the sunspots and makes some calculation about the sunspots. So this is his solar observing logbook, which obviously lasted for a really long time because he was just writing this little information per every observing session, and that's okay. On the right is a very famous page that I've seen in a lot of places, because this is from David Levy, who was a Canadian comet hunter. Again, I don't know him. Maybe Alistair and Joe know him personally. But anyway, he discovered, together with Shoemaker, Caroline Shoemaker, they discovered a comet that ended up impacting in Jupiter eventually, right? That's the story. And so this is his note from that day, which obviously is not again a piece of art or anything, but it's really famous because that was the first note that he wrote about that comet that he discovered together with Caroline Shoemaker, and so it's an historical piece of logbook, and so not everything has to be pretty. It doesn't have to be, it still has a relevance. So there is no pressure to making a piece of art or a beautiful sketchbook. It's just recording things for even your own sake and memory. And then please, the next page. This is another review logbook from Leo Enright, who, again, I forgot, maybe you know, Alistair, which center he is, but all of these people are Canadians. Kingston. And so he has this very, very well-organized note-taking procedure where on one side of the page, he will divide it in 6 circles and will just draw on a sketch the observations, and on the other side of the page, he will write his notes. And so there is a lot of solar observations, planet observations. He doesn't sketch that much deep sky objects, but his notebooks are also really interesting to go through. And then he has a lot of notes about, for example, this was about an eclipse and at least event. And so his notes about the band and who he was with. And so you can also record it, your companions, who you were, how much fun you had at that party, and things like that. Can you go to the next slide, please? And of course, this is my sketchbook or my logbook. So the first page on the very left is the index that I mentioned. So for every observation that I do, I make a little drawing that basically explains what's like a planetary nebula or a comet or a C for carbon star. I just kind of highlight the most significant thing that I saw that night. Then I explain the page, the objects that I saw, and the dates. So if I want to come back later, it's easier for me to remember, oh, when did I see M92? And in which page is it? And then I can see that. The page in the middle is my notes for Comet Neowise that I saw from a school nearby. So I saw this one with binoculars, and I had the binoculars in a tripod, and I was just drawing as I was seeing it. So this drawing was done on the field. And then the page on the very right is the sketch, my notes from a night where I went observing with Alistair in Wamaboon Lake, and we saw beautiful auroras. So I draw Jupiter because that's where we saw it, and it was really fun because there was a shadow. One of the moons was transiting Jupiter, and you could see its shadow very clearly, even though it was just by chance because I didn't know it was going to happen that night. But so we could see it, and it also made a drawing of the northern lights that we saw that night, which were really nice. So I think that's it. Oh, and the last page, if you go, yes, and I put some. So I put links to the observer form that I have shown in some pages before. So you can, there are a lot of different observing templates in the internet that you can use to record your notes, or you can use a blank sketchbook and do it your own format. But maybe at the beginning, it helps to have a form that helps you remember all the things that you will want to write. So there are a lot of forms, but I personally like this one from the Rask very much. So I put it in there. The second link is the link to the logbooks section in the Rask webpage, where they have an archive of these different logbooks. And I personally find it very interesting to go through them and see what other people wrote and how different can be. So many people do it in such different ways. And but everything is meaningful. So that's really nice. And then Jeremy Perez is a person from Arizona in the United States, I believe. And he's an amazing drawer. He makes very beautiful astronomical sketches. And he has this webpage with a lot of different forms and also tutorials on how to draw things like galaxies, comets, so on. So it's a very interesting webpage. And the Sky News article, it has, it's a very beautiful article about how you can notice more in your observations by drawing them, or by writing about them, or by recording them, or by just thinking about them loudly. I don't know, just talk about it. But when you spend some time seeing and noticing things, your astronomy observation can be so much rewarding. And so I think that's it, unless anyone has a question. And I do encourage everyone to keep a book from the beginning, because it's a lot of fun to go back through your notes and especially see your progress or your changes. Okay.
I have a question, but
Yeah.
do you ever run into problems on dewy nights where the pages or the pencil or whatever you're using?
I haven't, because actually most of my observations are done from my backyard. I have a handicap, which is that I don't drive. So I only can go out very rarely outside. And so my backyard doesn't get that much dewy. I do have, I do all my writing in pencil in my logbook. and I use a Moleskine sketchbook that has a little bit of a thicker page. If you can feel, it's a sketchbook, so it's not a very thin page. It's a little bit thicker. But I heard for some people that they use. I actually have it in here. They use Write in the Rain. You know this brand, Write in the Rain? It's a special paper. I don't know if you heard about it. It's a paper that cannot get wet. So, I mean, it just doesn't, it's a different paper made of, I don't know what it's made of, but it's all weather paper. So the dew wouldn't change anything. You can still write on it. It wouldn't get wrapped or spoiled or anything. And so this brand, Write in the Rain, has copy paper that I used for a while to print my observing forms. But I personally didn't like it very much because when you erase with the eraser, it kind of creates dodgy marks. But they also have notebooks. They have like books with this kind of paper. So you could use that, or you can use a sketching book, a logbook that is made of a sketching paper that is by default thicker than the normal paper. That's what I would say.
Yeah, one of the things that I typically did is I had a sheet of cardboard, which I put on top of the chart and on top of the logbook on the table. And then when I'd be using the charts, flip that off just to minimize the total amount of time that things might get wet. And usually if I was sketching, I'd be at the eyepiece with the clipboard, and so the sheet of paper is fresh, and generally speaking a sketch is under 10 minutes, so it really doesn't have that time to get wet. And then as soon as it's done, it's often underneath something else to keep it dry.
Okay, thank you.
Okay.
Someone has asked, what about keeping a logbook by using social media platforms? Certainly, I mean, anyone can use you can do it anyway. And there are, sorry, I meant to put it in there is a platform called Life Sky, I believe, that is meant for astronomy record keeping. So you can do it in there, or you can even, using like, I don't know, Facebook, I don't know, maybe you can, it's just that I personally don't like using my phone when I'm out observing because it destroys my night vision. So I like pen and paper, but that's everyone's preference, of course.
Yeah, and
so
again, depending on what you're looking at, if it's a very bright object like Mars or Jupiter, the amount of light is not a problem. But as soon as you start going into looking at galaxies, typically the observer is going to switch to some form of voice recorder, just so that you can spend time looking and not having to change, and you try and do, and also the sketches are typically, the ones at the eyepiece are rough sketches, and then the artists out there usually go in the day after or 2 days later and make it really nice based on their verbal comments that they made at the time. Okay, thank you very much, Berta. It's yeah, it's very important to I think do the logbook, and especially since so much changes in the early part of one's career as well. Like you said, your interests change, and that is kind of neat going back that far. Okay, so I'll switch over to the next part, and we'll talk about geosat flares, and I'll explain what that means. Well, first of all, the key word in there is sat, or satellite, and here is a diagram from Heavens Above. I've put the link on the main page, but just in case you're not aware of it, it's heavensabove.com, and it's free. But if you sign up, you can log in from anywhere as just a guest. But if you log in with your own credentials, it'll then record where your base location is. You can actually have several other saved locations. And then all of the information is then tuned to your needs. So right off the top, you can get 10-day predictions for things like the International Space Station, the Starlink passes, the Elon Musk bits, where the Hubble Space Telescope is, and that kind of thing. So as it happens, we're right in a really good set of time frame for the International Space Station doing nice passes, and it's a super bright object. It's basically, when it's up high, it's the brightest object in the sky. You might think it's a plane passing overhead with bright light on it, but it's steady, and it moves about the same speed as a high-flying aircraft. When I say speed, that's the angular speed, the amount of time it takes to cross the sky. In reality, the satellites are hoofing it quite. They make especially something like the space station circles the Earth in 90 minutes, which is 26,000 kilometers per hour. So they're really going nicely. But when you click on one of these hyperlinked dates for the passes, it will bring you to another page, which will be a map of the sky and the path of the satellite with a nice arrow showing you which way it's going, along with some time markers. And notice that it takes a whole minute when it's low to go just a small bit, but then 1 minute it crosses a large amount of sky as it's passing by higher up. So unfortunately, it looks like it's going to be cloudy tonight, but over the next few nights, the passes are all very similar. Some of them will be a bit lower, some of them will be a bit higher, but from our location here, the International Space Station does not go farther than straight overhead. So speaking of straight overhead, we have the Vega, the brightest, second brightest star in the northern sky. Arcturus over to the west is the brightest star by just a smidge. And over to the west-northwest is the Big Dipper. And but very prominent in the south these days, well, apart from the moon, and the moon's going to be closer tomorrow, to the very bright Jupiter. Again, it looks like a plane that's coming in for landing, but doesn't seem to move very much. And it's actually Jupiter, and right next to it is Saturn. And in just a few months, by coincidence, the December solstice on the 21st, these two will be so close you wouldn't be able to fit the moon in between them. So that'll be really neat. And then off to the east, rising up, very prominent bright orange, is Mars. And Jeff will be telling you a little bit more about that next week when he does What's Up in the Sky this month. But I wanted to essentially focus on the satellite for a moment, and I'll go into full screen mode with this. That should work. And well, just to assume that not everyone knows necessarily what a satellite is. It's anything, well, it's a human-made robot, basically. That anything bigger than a suitcase to something almost the size of a bus are up there. Typically, most satellites have solar panels. That's where they get their energy from. And we see them at night because they reflect the sunlight. Sunlight bounces off either the body or the panels. The body might actually be more circular or cylindrical. Some of them rotate normally, and others are try and keep a fixed orientation as they go around. And so when the angle is just right, the sun reflects off the panels and we see them. So why do we see them at night? And in this diagram, it's during the day, the satellite orbiting the Earth is in sunlight, but it's just the sky is so bright we can't see it. But when we're in the evening hours, we're in the Earth's shadow, the sky above us is dark, but higher up at about 400 kilometers or so for the low Earth orbiting satellites, they're still in sunlight. And so they will be shiny and they'll be moving. So we see them. And then at some point later in the night, they'll go into the Earth's shadow and go dark. And we'll see that with the International Space Station as well. For its later passes, you'll only see 2/3 or 1/2 of the pass. And at some point, the space station goes into the Earth's shadow and disappears. Now that's for the low Earth orbiting ones. For the farther ones that are out there, although they're in, they do pass into the shadow, because they're that much farther out, we get to see them over a much longer arc. And this isn't quite to scale, but the next one will be. What ends up happening, though, I want to mention here is that when, well, it started with the moon. Newton, Isaac Newton, was the first person to figure out how essentially gravity worked and why the moon, you know, what held up the moon. And it wasn't anything holding it up, but it was the fact that it was moving fast enough that it's constantly falling to Earth, but it's falling at enough speed that it just keeps its same altitude. And Newton also figured out that the closer in it is to a large mass, the faster it goes. That's why Mercury has a very fast orbit and Pluto has several hundred-year orbit, being that much farther from the sun. And so the same thing happens with satellites here. A satellite that's farther from the Earth moves more slowly. And at the dawn of the space age, the scientist and science fiction writer Arthur C. Clarke, famous for 2001: A Space Odyssey, but he figured that, hey, if we could loft a satellite far enough from the Earth, it would essentially take one full day to orbit the Earth. And because somebody on the ground also takes a full day to orbit, they would essentially, it would stay roughly in the same part of the sky 24 hours a day. And so that's here essentially in this. Here's a diagram to scale. The low Earth orbiting and the International Space Station, they're orbiting barely above, skimming the tops of the very thin atmosphere. But when you're out at 36,000 kilometers, this is the place where the satellite orbits at the same spin rate that the Earth turns. And so because, well, in Latin, the word for Earth is geo, as in geology. And because the satellites are not moving, they're stationary, we then call them geostationary satellites, or GeoSat for short. And we put communication satellites, and that's where all of, whoops, I was gonna have, I think, was it one more? We put all of our communication satellites in these orbits. So the big direct TV, people have their little radio dishes sitting out on their balconies, pointing up at a spot. They're pointing at this belt of satellites that this is where the satellites are. in our sky, where they are apparently stationary. And so this gap here is where the Earth's shadow is at the time that this was. So this was in mid-evening. At midnight, the Earth's shadow would be essentially due south because the sun is due north. And then as the sun is rising in the east, the Earth's shadow would be exiting over in the west. But where to find it at this point is you'll see the Great Square of Pegasus in the southeast. And then there's this sort of sideways Y. This star actually ends up being in Aquarius. And then there's this neat little asterism called the Water Jar. It's a lopsided Y. And then there's a neat little triple star down here. And I've got that on one of the images that I uploaded to the website that has the meeting date on it. So you can essentially find it by taking the right-hand side of the square and then going down 1.5 times, and you're right smack on that area. So that's where the geosats line up. Now, why would they flare? Well, the interesting thing is just like a mirror. You only get light reflected to you when, say, the sun is right behind you, reflects off the mirror and into your face. So what I did was I just took a drawing that one of my nephews did. It's got just glass in the front of the picture. Then I did a short exposure as I got closer and closer to lining it up with the sun. And so what ends up happening, imagine this is, say, a solar panel on a satellite. And as the sun gets closer and closer, it just brightens up until it's super bright. And then you can well imagine if you keep on going to the other side, it fades off again. And so these geostationary satellites, the peak is October 11th, they undergo these flares. And so it's actually possible to see one of these satellites. So they're smaller than an airplane, but it's 36,000 kilometers away. And you can actually see it with the unaided eye or binoculars. So I tried to see some last night, and we're not quite lined up yet. We're still in this kind of frame where they're only going to have a bit of reflection. But once we hit October 11th, or plus or minus a week, we'll be getting these, and they'll flare up just before they disappear into that shadow. So that's just kind of a neat thing. And especially because they are stationary, it's the stars that move past them, and they just sort of sit in the field. And so it looks, if you've got a tracker on your telescope moving, then the stars are still and the satellite will appear to move across. But if you've got it the other way around, you turn off your drive and you just look at this stationary satellite, and then the stars just sort of slowly drift by. So that's a kind of a neat thing to be looking for. So I'll move over to, I guess before I do that, are there any questions about these satellites? And that triplet I mentioned is right down here. This is the place to watch in the evening hours for these geostationary satellite flares. So as a reminder, Mars in the east, the Great Square of Pegasus up there, and you just go down the right-hand side about 1.5 times, and you'll hit the triplet.
I'd like to ask,
Sure.
regarding the lining up of the satellites so we can see it with the unaided eye or binoculars, how long does that take? Is it like a week-long process over the duration of the day?
The flare for it to rise in brightness and then fall off, that is only a matter of sort of 20, 30 minutes.
Okay.
Because the essentially it's what we do is, say for example, if there was a satellite right here near the triplet, where we want to be looking, as the sun lines up behind us, we on the Earth are in the middle. It lines up, and then the light goes to the satellite and comes back. So as it slowly lines up, it's kind of weird. You sort of say, well, it's the sun that's moving. Well, apparently the sun moves behind us, and as the sun sort of lines up, then the satellite flares, and then very soon it disappears into the shadow. So it just before it reaches its maximum brightness, or as it's reaching its maximum brightness, it disappears into the shadow. So I hope that answers your question there.
Yes, thank you.
Yeah. But yeah, for say the overall process of sort of plus or minus a week is essentially the line of the sun. If you imagine that the picture I was using, it would pass underneath it, and then during the perfect week it passes right through it, and then the next week the sun is lined up too high, or in this case the sun is going farther south, so the sun ends up going too far below that to get the perfect geometry from sun to the panel to us. Okay, I'd like to move on to one of the parts of the Explore the Universe certificate from the Royal Astronomical Society. So again, please download the PDF, print it out. And among the things that you would need to do to earn your PIN are identify some stars. So I've mentioned Vega, Deneb, Altair, the 3 bright stars of the summer triangle. Identify a planet with your unaided eye. So already, if you just sort of print that out, go outside and do that and identify them, you're already partway earning your certificate. But another part of the certificate is binocular double stars. And actually, we'll even start with double stars that do not require binoculars. So even if you don't have them, you can start, well, hopefully tomorrow night, it'll be clear. Over to the northwest where the Big Dipper is. Now you'll have to imagine it rotated. You'll be looking at it from the bottom side. But at the bend in the handle of the Big Dipper is the double star Alcor and Mizar. And that's been known for centuries, way back into even Persian astronomy, and back in the old Greek and Roman days. That was a test of somebody's vision, was, can you see 2 stars here instead of just the one? So if you could properly identify it, then it was like, okay, you can be an observatory assistant. So, and in the telescope, the brightest of the pair splits again into a double star. And speaking of that, right tucked in against the bright star Vega, which is almost overhead, a nice brilliant blue-white star. Right next to it is a tiny little pair. You can almost see on this diagram that it's an elongated dot, because there are actually 2 little dots beside each other. Now, chances are, if you're over the age of 50, your eyesight is simply not good enough to split the pair. But if you're anywhere from 5 years old to into your 30s, there's a decent chance just looking at this, you'll be able to see that, oh yeah, there's a little perfect little double star there. And in binoculars, it's very easy. Very obvious pair. And the neat thing is when you throw a telescope on it, the pair will actually split each one goes into a pair. So that's known as the double-double. And it was called that well before Tim Hortons ever existed. When we talk about looking for the double-double in the sky, we're talking about looking for this particular star. Now, nearby is probably the best one on the lot, Omicron Cygni. Just with your eye, you can see there's already 2 stars on the chart here. You can see that pair. But when you throw binoculars on it, the brighter one splits into a pair, and you can actually, with binoculars, see the colors. One is a sort of a topazy orange, yellow, and then the other 2 are bluish. And so that's probably the highlight of the binocular doubles is this one in Omicron Cygni. So just on the way from the bright star Deneb to our luminary Vega, just a little bit off, and boom, there it is. So that's my favorite. Following Vega up here, still up high in the sky, you'll see a pair of stars. Again, they'll be tilted over to the west-northwest as the evening progresses. And this is the head of Draco, these 4 stars here. It just looks like a little squash box. When you first step outside, you're probably only going to see the 2 brighter ones, but as you dark adapt, you'll pick up these other 2. Draco is a tough constellation. It was probably one of the later ones that I ever followed, because it goes sort of all the way over towards Cepheus, which is not an obvious constellation. Then it does this hairpin turn and arcs around and comes in between the 2 dippers. So it's really something to trace out when you're out of town in a darker sky. But at any rate, the head of Draco, the dragon, is this neat little double star, and you're going to need binoculars for this. And to try and hold them steady, probably just lean against the side of the house or prop your elbows up on the roof of a car. And then look, and you'll see just again this perfectly equal pair. And one of the new ones for me was this 16 and 17 Draconis. So I won't explain why they get the numbers 16 and 17, but just accept my word that a while ago there's an astronomer that listed all the stars in order in the constellation. So these are the 16th and 17th ones that are visible to the unaided eye. In the city, you wouldn't really be able to see them, but just take these 2 stars in the head of Draco and you go 2 to 3 times over, and again in binoculars, a perfect double pair of cat's eyes looking back at you. So that was actually the first time I've ever seen those. For some reason, there's not a lot of deep sky objects in this part of the sky, so it's not a region that I've really gone to before. Something else for the visual, no binoculars required person is down at the bottom where the summer triangle points down at the moment to the left of where Saturn is. You'll see 2 widely spaced stars, part of the constellation Capricornus. It's a tough constellation to see inside the city, except for these 2 stars here and the one at the tail. But each of these, Alpha and Beta, are themselves double stars. But the more obvious one is Alpha, and it's, again, just to the unaided eye, you should be able to see a nice little double out of it. Beta Capricorni, when I looked in binoculars, it was one of those things, I'm just kind of sort of shifting around. It's like, do I see a second one? Not sure. Yeah, there it is. No, gone. Oh yeah, it's there. You sort of, if you can really steady them, then it's there. So Beta Capricorni is actually probably the toughest one of the lot here. So that is the the binocular doubles to see. And again, that's part of the Explore the Universe certificate from the RASC. And so even if you see half of those, then that's all you need to get your certificate in the double star section. And then we'll also cover some more double stars as we get into the winter skies in a few months. I'm going to move on to upcoming meteor showers. Hopefully it doesn't cross too much into Jeff's realm. But, I wanted to talk a little bit, since we're coming into the Orionid meteors in mid-October and the Taurid and Leonids. Now this is actually the Geminid meteor shower in winter from a couple of years ago. Anything that is going horizontally is a plane that takes a little while to cross, but those little very fast flashes are meteors. Now, there goes a plane, but the flashes that you see coming down from the top in all these directions, I'll loop this again in a minute, are all coming from the constellation Gemini, which is up top. I'll start back again. Now, this particular meteor shower has 10 times the number of meteors that the Orionids do. But every year I see in the press or the media, it's the Orionid meteors set up to light up the sky tonight. And you know, you're sort of half expecting this fireworks show because they've got a great picture of a beautiful fireball. And it's, no, that's not what's going to happen. Sadly, but I love meteor showers because it's a great, particularly it's a social event for 4 or 5 people to spend some time out in the sky. And the only thing you need is a deck chair and your eyes to look up. And even if you don't really know anything, you just sort of carry on a conversation about what you're looking up in what you see in the sky. And some of the more expert people will tell stories of other meteor showers. And because especially with this particular meteor shower, it's rated at 15 per hour, but that's an ideal condition, which we don't actually get. And so we really only get about 8 per hour, meaning that because they come in randomly, you sometimes will see 2 in 2 minutes and then nothing for 15 minutes. So it's not something to just waltz outside and look. And this is from a dark sky for the Orionids and into November with the Taurids and the Leonids. You need patience and to be dressed really warmly to make up, to beat against the chill that's in the sky. And the other thing that is often not said about the Orionid meteors in October coming up is that if you start looking before 10 p.m., you will see exactly 0 meteors because the Earth is actually blocking the meteors from getting into our sky. They're grains of sand burning up in the upper atmosphere. And so it won't actually be until about 3 a.m. till you start seeing the 8 per hour or, you know, one every sort of 8 or 9 minutes or so. As much as I'm kind of downplaying the meteor shower, it's a double-edged thing. Meteor showers are wonderful, but they're there. You want to just sort of relax and not expect fireworks.